Hi, welcome to the Olympiad geometry. Let's continue our study on Ceva's theorem. Let's see the problem. Tau is a semicircle. The diameter is on line L. CD are any two points of tau. Let CB, DA be tangent of tau, and CB intersects L on B. DA intersects L on A. AC intersects BD on point E. EF intersects L on F, and EF is perpendicular with L. Proof: EF divides angle CFD equally. That means we want to prove the angle ECFE equals to the angle DFE. And the first, so we got this problem here, and we know that we want to prove the relation of two angles. And we know we have the condition of two tangent points, which means we should directly connect them to the center O, where we can get CO perpendicular with CB, DO perpendicular with DA. And we know we have another perpendicular line that EF is perpendicular with line L. So what we can use for of these conditions? The very first thing we can think about is that because this is the CF, the OC is perpendicular with CB, right? And EF is perpendicular with BO. That means if we extend the EF and intersect with CB, then we got triangle CBO similar to that triangle. And we can have something similar here. But we cannot associate these two. So to address this issue, let's do a study for this figure first, right? Let's do this. We extend the BC, we extend the AD and intersect them together on the point, let's say P. And now if we do because EF is perpendicular with BA, as what we think about before, we want to find some similar relations, right? So we do, let's call this H. We do PH perpendicular with BA and intersects BA on H. And now we know that the triangle BCO is similar to the triangle BHP. Triangle ADO is similar to triangle AHP. Right? Because for the CBO and the PBH, they both are right triangle. They also have share the angle PBH, similar for the right half. And what we can get from this similarity, we got the ratio that CO to PH equals to CB to BH, right? CO to PH equals to CB to BH. Similar here, we got DO to PH equals to AD to AH. We want to find AD to AH. right? DO to PH equals to AD to AH, AD to AH. And we know that CO equals to OD equals to the radius of the semicircle. That means CB divided by BH equals to AD divided by AH, which means CB divided by BH times AH divided by AD equals to 1, right? CB divided by BH times AH divided by AD equals to 1. This reminds us something, right? Because CB divided by BH and then we do HA divided by AB. That means we have the line of AC, BD, and PH. So that means for the triangle PBA, right, for the triangle PBA, the line BD, CA, and PH are concurrent. Why? Because if we already have this relation here, this production with valid is here, so we got CB divided by BH times AH divided by AD and times DP divided by PC, right? Because PD equals to PC, so this equals to 1, this equals to 1, this equals to 1. That means if we use the converse of Ceva's theorem, we got this relation that BD, CA, PH are concurrent. Now we know that BD intersects AC on point E, and PH also through point E. We know that PH is perpendicular with BA and EF is perpendicular with BA, which means PH and EF are on the same line. Right? We got that PH and EF are on the same line, so it's actually P through E to F. And now we see here OCPD. Because the angle OCP equals to the angle PDO, that's 90 degrees. So OCPD is cyclic quadrilateral. Is a cyclic quadrilateral. And we also see here OP, because this is 90 degrees, so the OP is a diameter. And we also know that angle OHP equals to 90 degrees. So because angle OHP is 90 degrees, that means H is also on this circle. Right? H is also on the circle. So OCPDH are on the same circle. H is actually point F because they are the same, right? So we just let's bend the point H. So it's F. OCPDF are on the same circle. Now we look at PC and PD, right? Because PC equals to PD, that's the same chord on this circle, which means the angle CF FP equals to angle DFP, right? Because the chord are the same, PD and PC are the same on this circle. So the angle of these two chord relevance to that means DFP for the chord PD and angle PFC for the chord PC, they are equal. And now we prove that EF divides the angle CFD equally. This problem is not that easy because you need to figure out, we want to find the relation of the BC and DA. We have to extend the BC and DA, and then we have to find that PEF are collinear, right? Once PEF are collinear, we know that because we already know CODP is a cyclic quadrilateral, and then we can easily prove that F is on the same circle, and because CP equals to PD, so we got that these two angles are equal. This is not that simple to do, but it's I would say it's a immediate difficulty level. So that's a problem. I hope you like this video. See you in next one. Thank you.